So this is Spark. First thing you'll want to do when you open up Spark is make sure that you have the correct desired output and input devices selected. So in this case, we can see that Spark is outputting to my AirPods, but I can also see other devices that are connected to my machine. By pressing this test button, a sine tone will be played back through whatever device is selected. That way you can tell that the audio is actually coming through. And then for input, we could see my laptop's microphone selected. Other devices are available as well. And we can see that the input is being received because this meter here is indicating that it's being picked up. Now, if we switch this to another device, we can see I now have multiple input channels to choose from, because I may have a microphone for recording vocals and a line in from an electric guitar, for example. With our current implementation, you're going to just select one of these inputs as active, and you can also, if you had multiple outputs, which is a more rare situation, you could select which outputs you wanted. And then for more advanced users, most people shouldn't have to go in here, but you can look at these advanced settings and adjust the sample rate or the buffer size. The buffer size is more important for the average user because it can help. You may want to adjust it depending on the processing power you have. So by selecting a smaller buffer size, you're decreasing latency, indicated in the milliseconds in the parentheses here, but that comes at the cost of additional processing power. So if your computer's not very powerful, you will need a bigger buffer and have to live with some more latency. Anyway, so that's advanced settings. Once you have your input devices correctly selected and settings set how you want them, you can select a folder. So we have created an example folder here. Inside of this folder, we see several WAV files. Each of these WAV files is a mixdown of a project that was made in a full digital audio workstation. And by opening this folder, we can see playback these particular mixdowns like so. Here are all of the mixdowns loaded into Spark. You can select them from this menu. You can skip through them with the next and previous buttons. You can also skip while playing. And then while you're listening back to a track, you can record. You see you can see my microphone audio being picked up now. Now what I've just done is recorded a layer that can now be used and layered in another application on top of this main mixdown that we're listening to here. And in case this wasn't clear earlier, this is a transport for the currently selected mixdown. You can see as it changes, we have different waveforms loaded into this visualizer here, and you can select different points in the waveform to play from those points. Once you have layers recorded, you can navigate using your system's file explorer back to the folder which you opened up, and we can see that for every mixdown in this folder, there is an associated subfolder that contains the layers which have been recorded using Spark. In this case, we have 17 layers, each of which could be dragged into another audio program for audio editing, and each of these will be in alignment with the original mixdown, which is very convenient because it means that as a mixer, as an audio engineer, music producer, you can easily use these files that you've recorded through Spark. And the convenience of Spark is that you don't have to open up an entire heavyweight digital audio workstation just to record one of these little layers. So it's very nice for that inspired capture, and it means that you can avoid the process of loading a bunch of plugins into RAM and dealing with licensing issues, the issues that you have to deal with when you're loading up a full-on DAW project.
Alongside the demo that we demonstrated, we have both key accomplishments and technical challenges that are not easily visible just from the demo. A major accomplishment includes the ability to utilize GitHub Actions to streamline the utilization of CMake to build both the Mac and Windows versions. However, this accomplishment was not fraught with technical challenges, as Windows building is straightforward with Visual Studio, but we have difficulty building through CMake due to a number of missing header files. Testing is also streamlined through the GitHub Actions workflow, as it allows us to create tests and automate testing upon repository changes. Some complications surrounding testing has to do with the difficulty to add tests, but also the fact that it required a separate repository to test. Another accomplishment lies in our project manager. This was a class that helped to abstract away the idea of holding directory files and directory folders, which allowed us to shift the bearing of responsibilities for some of our components. The problem that this helped to alleviate is still one of our biggest problems, though, in that many of our components are too tightly coupled. Finally, an issue that plagued us the most during the conception of Spark was the usage of C++ and Juice. Most of us were novice C++ programmers, and Juice was also a really well-rounded but incredibly heavy framework. It lacked the forum and community of audio developers and programmers, so a lot of the programming that we did was done from the ground up. C++ also had a lot of nuances that were different from the prior languages that we had exposure to. A notable accomplishment that came from the usage of Juice and C++ was the management of threads in order to constantly update the state of the program in multiple components, particularly in the playback and the slider components. Another was the usage of OS detection. We used OS detection to help with allowing OS-dependent components to work. Some OS-dependent components were things such as dragging and dropping files, testing files, and even certain audio device settings. When it came to features and cuts, the major functionalities and features that we were able to complete included GUI, quick browsing, basic recording and saving of layers, and the adding of filler onto recordings to line up timestamps. The one that we were not able to complete is the loop back of specific sections in Mixdown. We were only able to partially finish this, mainly because we prioritized the other 4, because we felt that they would fulfill the needs of our user average use cases that we had set up in our requirements prior. We also felt that it very much heavily depended on these prior 4 features, as Loopback would have to focus around the playback and the recording functionalities. And since we went through a lot of different iterations, as well as bug fixes around these, we were unable to properly finish the loopback. When it came to extra features, we completed only one of the extra features that we had set ahead for us, that being the audio input check and or meter. A lot of these stretch goals were quality of life assurances that would help the average user a lot with just the use, just the ease of usage, as well as adding some efficiency to the application. We set up a lot of the code in order to implement these in the future. Examples of this are in the file directory change listener, which we had to scrap some of the work, as there were many problems with directory change listeners when it came to different OSs, and we couldn't find any real library that did that for us. Another one was the user gets to choose where to save layers. We practically have a way to allow for this, and it's going to most likely consider some sort of button. We do not currently have the deleting recorded layers or undoing deletions. Audio device selection as hidden separate view is not much more difficult than what we currently have, as we have it embedded in a main window with everything else. Dragging multiple layers out of applications directly into DAW is not something that we have currently done. Recording the MIDI is not something that we have done either. Recording layers is automatically discarded if volume too low is not that hard of something for us to implement, as we do have ways to measure the volume implemented, but also ways to discard layers. Introductory tutorials and help guide is something that we are going to do in the far future, but it's not currently implemented at all. Quick open project in DAW of choice. This is something that is very high in priority, but it is not currently implemented. And finally, opening from the last opened directory is something that we have code for, however, it was not finished. When it came to roles, we assigned each team member a role based upon their preferred use case. We would be implementing the main components that were detailed to these use cases. For Tuan, that was opening the mixdown folder. For Mark, that was skipping and previous mixdowns. For Nolan, that would be record layers. For Jay, that was playing back the mixdown. However, as the quarter went on, we redefined these roles, and in the end, Tuan, who was me, did the opening of the mixdown folder, skip/previous mixdown, as well as playing back the mixdown. I acted as both the software designer and programmer for these components. I also helped in the conception of the Google testing automation. However, we ended up scrapping that for the unit test runners. Next, we'll hear from Nolan.
As far as roles and responsibilities go, in the end, I ended up playing more of a project management clerical role, and facilitated some communication and documentation. But I also made some contributions to the architecture, design, and implementation, with a focus on the recording functions.
My name is Mark, and I was originally assigned to the previous /next function, but due to some personal difficulties, I later shift my focus onto Windows build. And one of the biggest challenge during that time was there was missing a critical header file called wmsdk.h. And after digging into it for a while, the Windows build we have currently, it works with the proper Windows 10 SDK development kit. And next we'll have Jay.
So yeah, I was initially in charge of playback, so I worked on prototyping potential playback features, like including a waveform thumbnail and scrolling. But due to building and testing being more difficult than we expected because of unfamiliarity with C++, I decided to switch focus to the automation of building and testing for a workflow on GitHub Actions, as well as just building on Mac. One of the major issues this time around was having very little testing. It was difficult to incorporate unit tests into our application because the correctness of this app's function is very user dependent and not really easily generalizable to unit tests. The testing framework that we got to work was unintuitive to use as well, the JUICE testing.
Yeah, and as you mentioned, for testing and tooling, code reviews and testing were definitely a lacking part of our group meetings. Part of the reason was that we took a lot of time at the beginning to figure out which tools and language we wanted to use. And we ended up using C++ with JUICE, which we weren't really familiar with, and which caused us to have to take a good amount of time to become comfortable with it. We have found that C++ is a difficult language to pick up quickly, which left us scrambling with development a little bit. Toward the last few weeks, we did start incorporating code reviews through pull requests. For example, in one of Tuan's pull requests, Nolan pointed out that the stop button resets playback to the beginning of the mixdown, which could be seen as a bug or a feature. If we were to change something, we would probably like to do more in-person code reviews because it would help promote healthy discussion about why certain features should be written in specific ways. If we go off of the previous example, it will help clear up issues with whether certain features have their intended functionality or not, and potentially save some time.
We spent a lot of time deciding which technologies to use, which threw off some of our processes that weren't as relevant to making the app minimally function, and as a result, the estimates that surrounded our planning. Our planning was more balanced between implementation, documentation, testing, whereas in reality, we were forced to spend a lot of time on implementation over testing and documentation. Our plans did somewhat account for this because since we were all new to the technologies that we used to implement and test this project, we expected some amount of difficulty with balancing these different categories. We also weren't entirely sure what kinds of tests would be appropriate for our application, which affected the accuracy of our estimates surrounding that.